Today's notes, we are going to talk about the attributes of transformed functions. That's things like domain, range, your x and y intercept, etc. So the notes are actually going to be on the back of this page at the very bottom. If you're absent last class, make sure that you get a copy of the notes so that you can write these down. But we're going to start working through those. So now that we know where our transformations are in the equation, we can graph the absolute value function without actually plugging in all of our values and creating a table of our x and y coordinates. So let's look at number 11. I know based on the transformations from last class that the x minus 1 is going to shift right 1, because remember this goes opposite what we think. And I know that the d value down here of -1 is going to shift down 1. So looking down here at my graph, I'm going to take my vertex of my parent function. I'm going to just sketch it out here. Not that we need it anymore, but there's my parent function. And I'm going to move the vertex 1 to the right and 1 down. So that's going to put the new vertex at the ordered pair 1, -1. Okay, after that, let's look back at our equation. I don't see any a value out there in front of my equation. So my slope is still going to be 1 on both sides. It's not negative a value, so it's going to just be 1/1 on both sides of the absolute value function. Okay, so we get something that looks like this. So that vertex is going to be considered a minimum because it's the absolute lowest point on that equation. Working from the top down, my axis of symmetry did change because my axis of symmetry is now through x equals 1, not x equals 0. So it always goes through the x value of your vertex. So my axis of symmetry is x equals 1. Okay, domain for this whole entire unit is always going to be all real numbers, because regardless of if your absolute value is pointing up or pointing down, it's always extending to the left and extending to the right. So there's nothing that's going to change that. It's always going to be all real numbers. So I'm going to say from -infinity to +infinity. Okay, my range though, if I read this graph bottom to top, the lowest value or the first value I get to is y equals -1. So I have a y, I have a -1, and all of the other y values on the graph are going to be above that. So y is greater than or equal to -1. Okay, we can see our x-intercept on this graph is at 2, 0. That's where we cross the x-axis. And my y-intercept is right here at the point 0, 0. Now, they're not always going to lie on exact points. So if we wanted to calculate our x-intercept by hand, you plug in a 0 for y. Okay, you're going to notice if you look back at this graph that not only is this a y-intercept, it's also an x-intercept. So we're not going to solve this by hand yet because we don't know how to solve absolute value and get our two x values. Okay, so we're going to also list 0, 0 as an x-intercept. So it's possible to have one x-intercept like our parent function, 0, 0. It's possible to have two x-intercepts, and it's also possible to have 0 x-intercepts. If that vertex was shifted above the x-axis and still pointing up, we would not cross the x-axis. Okay, so if we wanted to find it by hand, we would plug in a 0 for y, but we don't know how to solve those yet. Okay, same thing for y-intercept. We would plug in a 0 for x. That we do know how to do. Okay, if I put in a 0 for x up here, 0 minus 1 is -1. The absolute value of -1 is 1. And then I still have that -1 at the end. So if I plugged in a 0, I would get out a 0. So right here, plug in a 0 for x, get out a 0 for y. My intercept is at 0, 0. Okay, if you recall, if I have x minus 1 in the equation, that tells me that I have a positive C value. So here my actual C value is equal to 1. My D value is equal to -1. That's always going to directly correlate with your vertex. So your vertex here is always going to be C comma D. So without graphing it and without shifting the vertex of the original function or the parent function, you're always going to be able to figure out that vertex. Okay, so let's look at this next one. I've got g of x equals 1/2 times the absolute value of x minus 2. So I've got an a value of 1/2. I don't have a c value. So really I have +0 or -0 in here. So we could say our c value is 0. You'll see in just a second why I say that. And then our d value over here is -2. So if I'm writing my vertex, c comma d, my vertex is at 0, -2. Okay, I also mentioned on the previous example that the axis of symmetry always passes through the x value of your vertex, because your axis of symmetry always passes through the vertex right here, and it's always x equals. So you can say that your axis of symmetry is on the line x equals c. So here my c value is 0, so my axis of symmetry is at 0. So let's go ahead and graph this and see if that's true. So I don't shift left or right because nothing is in the absolute value, but I am going to shift down 2 from that d value. So I'm going to go ahead and shift down 2. So right here, my vertex is at 0, -2. Now, my slope is my a value. So I'm not reflecting it. I'm still going up and to the right, 1/2, because my slope is 1/2. We can also go up and to the left to get our other side of our absolute value. So this one has been vertically compressed. We've spread out the legs. They're farther away from the y-axis. Okay, once again, this vertex is a minimum because it's the absolute lowest point on the graph. So minimum always looks like this. Maximum would be if we were reflected and the vertex was the highest point. Okay, so we said based on our C value, our axis of symmetry is the line x equals 0. So if I drew this x equals 0, if I fold that orange graph along that line, the left side will land on the right side. Okay, once again, my graph goes all the way to the left, all the way to the right. My domain is all real numbers. This time I'm going to put it in set notation, just so you're seeing it in different notations. Okay, my range, bottom to top, the lowest number I see is -2. So I have y is greater than or equal to -2 because I go up from that point. Okay, my x-intercepts, if I look on the graph, are at -4 and +4. So I've got -4, 0 and +4, 0. Okay, lastly, my y-intercept is right here at 0, -2. So your range is going to be directly tied to your d value. So we can get more attributes from that. I want to point that out because in this next example, you're going to see that the range looks a little bit different, but it's still going to be directly tied to that d value. So let's first get whatever we can from the equation. So here I've got c equal to -1, d equal to -3. So I know that my vertex is at the ordered pair, -1, -3. Okay, based on that, my axis of symmetry is at x equals -1 because it's x equals my c value. And my domain is going to be all real numbers. So I'm going to write it in the third notation. So all 3 of these domains are exactly the same thing in 3 separate notations. Okay, let's go ahead and graph this. So I know that my vertex shifts left 1 and down 3, and part of my graph got cut off. So you're not going to really be able to see much on here. Okay, what I notice with my a value is that it's going to be a reflection vertically, and it's going to be a stretch because the 2 is greater than 1. So reflection means that we're going to point downward. So I've got a slope of 2/1. So 1, 2, and then over 1. 1, 2, and then over 1. So it's going to look like this. Okay, if I were to extend this down, this is -4 and this is -5. So this is an example of where we do not have an x-intercept because we're pointed downward and we're shifted below the x-axis. So here we would say that there is no x-intercept. For the range, if I read this graph bottom to top, the lowest value I see is -infinity. The highest value I see is -3. So we could say in interval notation, we go from -infinity to -3. We can put a bracket. Or another way to say is y is less than or equal to -3. Because from -3, from this point, we go down. So you'll notice the first two ranges were positive, greater than, because we faced up. This last one is less than because our graph is facing down. And that's directly related to having that -a value. So -a is always going to make your range less than or equal to. But it's still, like I said, directly tied to your D value. Okay, you can see down here that my y-intercept is at 0, -5. And this vertex is an example of a maximum because it's the highest point on the graph. It's like a mountain. You're standing on top of the mountain when you're at the vertex and then going down from there. So your assignment today is called Transformations and Attributes. You are writing down all of the transformations and all of the attributes for the functions given. You're going to graph the equation. I want you to try to graph it by hand based on your transformations, but if you need to use your calculator, you may. But you're going to complete all of those and turn it in.